Good morning, everyone. This is Dr. Turner for Integrated Math 3. Today we're getting into Unit 9. 9.1 is looking at the law of sines and the law of cosines. We've been using a little bit of trigonometry in the past couple units. We introduced concepts of how to solve for a missing side. Of course, we've looked at that with the Pythagorean theorem, and then we introduced how to solve for missing side using sine, cosine, and tangent. But primarily we were looking at right triangles. The law of sines and the law of cosines are ways to solve for a missing side or a missing angle potentially, and that's going to allow us to solve for any side or any angle of a triangle depending on what's given to us. So let's go ahead and get started here. To start out, we're going to start with the law of sines. Law of sines start a new page here. Our law of sines is looking at a triangle, and again, it doesn't have to be a right triangle, so let's do so for law of sines, we have a triangle. We're looking at obviously three sides and three angles, and what is sometimes confusing for students when they're looking at this in, let's say, the textbook is that we use the same letters to represent both the sides and the angles. The difference, though, is going to be that the angles are going to be referred to as capital letters, and the sides are going to be referred to as lowercase letters. So let's say we have triangle here, ABC. And so each of the sides opposite we're going to refer to with the lowercase letters. So lowercase a, lowercase b, and lowercase c. Now the law of sines is that there is a proportion between a side length and the sine of the angle opposite that side. So a over sine A is equal to b over sine B is equal to c over sine c. Now we only need two of these to be able to solve for a missing side or a missing angle, but there are going to be some relationships that will work, in which case we're going to use the law of sines, and there are going to be some situations where we're going to use the law of cosines. Law of sines is applicable when we have either two angles and a side, so it could be angle, angle, side, or angle, side, angle, and that's the given information, or if we have two sides and then the angle adjacent to it. So side, side angle, for instance. But basically what this works out to is that we either need to have two sides and one angle opposite, or we need to have two angles and one side opposite. So what does this actually look like? So let's say we have a triangle. Let's say this angle down here is 48 degrees. We have one side that's opposite, let's say it is 12 centimeters, and then we have another angle up here, let's say it's 80 degrees, and we want to find the missing side. So looking up here, we have angle, angle, and a side in order, so that means the law of sines is applicable. So to solve for the missing side, we're going to use the law of sines. So we have the side that we're given, 12 centimeters, over the sine of the angle opposite it, in this case the sine of 48 degrees, and that has to be equal to the side that we're trying to solve for, x, over the sine of the angle opposite it, which is sine of 80 degrees. Now more than likely you're going to be using a calculator to solve this, whether you're using Desmos or for any calculator. So you can use a decimal approximation for sine of 48 and sine of 80 right now, or you can do the arithmetic and then put it all in one step. So to solve for x, you would cross multiply. So you have sine of 48 degrees times x, and that is equal to 12 times sine of 80 degrees. To get x by itself, you would divide by sine of 48 degrees on both sides, so 12 sine of 80 degrees over sine of 48 degrees, And from here, this is where you would use Desmos to solve or use a graphing calculator to solve. So let's say I'm using Desmos. So 12 sine of 80 degrees, and that is divided by the sine of 48 degrees. Now remember, we said that if you're using Desmos, the default is radians. So if you click the little wrench in the top right, you need to go down to degrees if you're using Desmos. Here it ended up being about the same, but still, just make sure it's in radians. We end up with 15.902. So our answer here for the missing side is 15.902 centimeters. A couple things you want to be familiar with. Remember your rules from Integrated Math 1, that in a triangle, the largest side is always opposite the largest angle, and the shortest side is always opposite the shortest angle. So let's say I did this and I got a number that was less than 12 centimeters. Well, that should be a red flag because 80 degrees is bigger than 48 degrees. Therefore, the missing side x should be bigger than 12. So little things to just pay attention to. Sometimes in these examples, you might also be asked to solve for, two missing sides. So let's call that z. And let's say I ask you to solve for z. Now, if we're using law of sines, we still need to be able to set up a proportion. And here it doesn't give me the third angle, but I know that the angles of a triangle have to add up to 180. So I would do 48 plus 80, which gives me 122, and subtracted from 180 gives me 128 rather, and subtracted from 180 gives me 52 degrees. Now we can set up a proportion. So we can use 12 and 48 again, 12 centimeters divided by the sine of 48 degrees. That is equal to the side we're trying to solve for now, z, over the sine of 52 degrees. Just like we did in the first example, we're going to cross multiply first, so we get sine of 48 degrees times z is equal to 12 times the sine of 52 degrees. Divide by the sine of 48 degrees on both sides, so 12 sine 52 degrees divided by sine of 48 degrees. Then we're going to use our calculator. So 12 sine of 52 divided by sine of 48 gives me 12.724, and these are centimeters. So with law of sines, as long as you have either two angles and a side or two sides and an angle, you set up the proportion and you can solve for the missing value. That's when you would use law of sines. Law of cosines is also going to be looking at a triangle. Okay. And same thing, we're going to be using those same letter patterns A, B, C, where the sides opposite are the same letters but lowercase, so lowercase a, lowercase b, lowercase c. Okay. Law of cosines is used rather than angle, angle, side, angle, or side, side, angle. Law of cosines can be used when you have three sides or when you have two sides and the included angle. Now, law of cosines, depending on which side you are solving for, can be written a little differently, but essentially what it is the missing side squared is equal to the sum of the other two sides squared, and then you subtract 2 times the other two sides times the cosine of the angle opposite the side you're trying to solve for. So it's a squared equal to b squared plus c squared minus 2bc times cosine of a. That's written if a was the side that I was solving for. It's going to look very similar if I was solving for b or c. So if I'm solving for b squared, it's going to be, again, the other two sides squared minus 2 times the other two sides times the cosine of the angle opposite the side I'm trying to solve for. And if I'm solving for c, then it's going to be a squared plus b squared minus 2ab times the cosine of the angle opposite. So the most common examples involving law of cosines are going to be where we have two sides and we want to solve for the third side. Now if this was a right triangle, that'd be easy. We'd just use Pythagorean theorem. And this should look kind of similar to the Pythagorean theorem, except that this is not a right triangle. So it's kind of the Pythagorean theorem, but then we're subtracting this difference, which is accounting for the angle not being 90 degrees. Okay. So c squared equals, let's say I have 8 centimeters and 7 centimeters, and I want to solve for this missing side, which would mean I would need the angle here inclusive, let's say 40 degrees. So if I'm solving for the side opposite A, then I'm using this top formula here. This would be a squared equal to 8 squared plus 7 squared minus 2 times 8 times 7 times the cosine of the angle opposite side, the side I'm looking for, which is cosine of 40 degrees. Now you're going to be using a calculator anyways to do the cosine, so if you want to do it one step at a time, you can. 8 squared and 7 squared you could do without having to use calculator potentially, but we're going to then need to subtract 2 times 8 times 7 times the cosine of 40 degrees. Okay? Once we do all that, then we need to take the square root. So if you're using a calculator anyways, using a calculator anyways, you could do this in a single step, or if you're using a hand calculator, you might need to take a couple extra steps. But as long as you can show your work and justify how you got your answer, we end up with 5.216. So A equals 5.216 centimeters. Okay, like so. Let's do one more involving law of cosines. Now, for law of cosines, we also said that you can use this if you have side, side, side. So let's say I have, and we'll do something other than centimeters. Let's say we have 10 inches, 13 inches, and 11 inches here. And I want to solve for angle A. Okay. So using law of cosines, I can do that so long as I have, again, 3 pieces of information and I'm solving for the fourth. So because A is the angle that I'm trying to solve for, I'm going to use again that first formula. So I have the opposite side, 11 squared, and that's equal to 10 squared plus 13 squared minus 2 times 10 times 13 times cosine of the angle, and the angle is what I'm trying to solve for. So 11 squared gives me 121, 10 squared gives me 100, 13 squared gives me 169, and then 2 times 10 times 13, that gives me 260 cosine A. Do a little bit of arithmetic. 100 plus 169 gives me 269. Isolate the variable term. I'm going to subtract 269 on both sides. Okay. Then I will divide both sides by 260. So cosine of A equals 148 over 260. I'm going to use the inverse cosine function. So cosine inverse of 148 over 260, and remember this is in degrees. So angle A in this scenario is approximately 55 degrees, like so. That's it for today, guys. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.